Today we're going over Chapter 11, 7 Dilations on the Coordinate Plane. So the first thing that we need to go over is the word dilation. The first thing that I think of is when you get your eyes dilated at the doctor and your pupils get bigger. So what a dilation is it's a transformation, just like our rotations and our translations and reflections. So it's a transformation that enlarges, or in the opposite direction, reduces. Sorry, that's supposed to say reduces a figure by a scale factor. So it's a transformation that enlarges something or reduces it by a scale factor. So if a figure is dilated, what words could we use to describe the relationship between a figure and its image? So with our rotations and our translations, and yesterday or in our last lesson, I should say, we were proving congruency. We were proving that they were congruent, that they were the same. Well, now, making something bigger or smaller, they're not going to be congruent anymore, but they are going to be similar. So here in our next slide, it says how to find new coordinates after a figure has been dilated. So what you do is you take your original coordinate, and our new one says dx, dy. What d stands for is the dilation. So if your scale factor is 7, what you're going to do, and let's say we have 3, 2, with a scale factor of 7, we're going to take 7 times 3 and 7 times 2 to get our new coordinate of 21, 14. So all you do is take your coordinates and multiply them by whatever your scale factor is. So this example says a figure has vertices J, K, M, and N. We want to graph the figure and the image of the polygon after a dilation with a scale factor of 1/2. So if our scale factor is a fraction that is smaller than 1, do you think we're going to get bigger or smaller? Just something to think about. So we've got J, K, M, and N. And since it's 1/2, that means we are going to take 1/2 times 2, which would be 1. So our new values, and we're going to take 4 here, times 1/2, which is 2. 2 times 1/2 again is 1, and 6 times 1/2 is 3. 8 times 1/2 is 4, and 6 is 3 again, and 8 is 4, and 2 is 1. So then we can go graph both our original figure and the image. I'm going to graph our original in black. So 2, 4, 2, 6, 8, 6, and 8, 2, I guess I did. So here is our original figure. Not the most beautiful sketch you've ever seen. I hope yours looks a little better than mine. And now I will graph our new figure here in red. So this here will be all in red. So we have 1, 2, 1, 3, oops, this one here, look, 8, 6, it should be 4, 3. So just caught that one, 4, 3, and 4, 1. So here is our new figure. And look at that, what happened. With our scale factor of 1/2, our original figure shrunk by 1/2. Now we have a triangle with vertices 1, -2, 0, 2, and -2, -1. And find the coordinates of the triangle after a dilation with a scale factor of 2. So if over here in our scale factor of 1/2, our shape got smaller, what do we think is going to happen with our scale factor of 2? So first things first, let's graph our original. So A is at 1, -2. B is at 0, 2. And C is at -2, -1. So there's our original figure. Now our new figure, let's write with this pink for now, will be A prime, B prime, C. And so we're going to multiply all of our coordinates by our scale factor of 2. So 1 times 2 is 2. -2 times 2 is -4. 0 times 2 is still 0. And 2 times 2 is 4. And -2 times 2 is -4. And -1 times 2 is -2. Let's plot our points. So we will have 2 to -4 here. 0 up to 4. And -4 to -2. So our new shape, I wish my lines were straighter, sorry, grew. So it went times 2 bigger. So when your scale factor, remember that would be, I'll just write in pink, the number you multiply by. Your image will get larger if, like here, your scale factor is greater than 1. Your image will get smaller if your scale factor is less than 1 but greater than 0. So basically if it's a fraction. And finally, here's a real-world example for you. The drawing of the school logo is to be enlarged, as shown down here on our table, or a graph, I apologize, so it can be printed on the gym doors. What is the scale factor of the dilation? So now we have our points. So we have our original of 1, 3, and 3, 3. So that's our OG, right? Our original. And our new of 3, 9, and 9, 9. So we need to figure out what is being multiplied to our original to get our new. So I know 1 times 3 is 3, right? We can all agree that that is an accurate statement. So let's test and see if that works for everything. 3 times 3 is 9. Sweet. And it's 3's all across the board. So our scale factor here is 3. You are ready to go ahead and work on your assignment.